Hey guys, so I just wanted to go over this diffusion and osmosis worksheet that I gave you for homework. I know third bell, we did go over a couple of questions, but fourth bell, we did not. So you're going to answer questions 1, 2, 3, and 4 using your notes. Then for numbers 1 through 9 at the bottom, I'm going to show you how to solve these. So for each beaker, you have to follow the directions at the top, A, B, C, and D. A tells us to draw an arrow to show which way the water will move by osmosis. B says if the solute is able to move, draw an arrow to show the way that it would move by diffusion. C says to draw and label what would happen to the cell as a direct result of the diffusion and osmosis. So will the cell shrivel? Will it swell? Will it stay the same? And then you have to finally tell what type of solution the cell is in. So let's do number 1 together on the front here. The first thing I need to do is draw an arrow to show the way that the water would move by osmosis. I'm going to draw my water arrows in blue. In order to decide which way the water would move, I need to look at the numbers inside of the cell and inside of the beaker. So the first thing you should notice is that in the cell, the percentages will add up to 100. 90 plus 10 gives us 100. In the beaker, same thing. 85 plus 15 gives us 100. Okay. For A, we're only looking at the water percent. So inside of the cell is 90% water, and outside of the cell is 85% water. I need to compare those numbers. Which one would be the biggest? 90. So we know that in osmosis, the water is going to move from where there's more water to where there's less water. So there's more water, there's 90% water in the cell. Okay? It's going to move, the water will move out of the cell toward into the beaker where there's only 85%. It's going to move from highest concentration to lowest. All right, so we've done A. Now we're ready for B. In B, we have to tell which way the solute would move by diffusion. So we're just going to look at the concentration. So in the cell, there is 10% of solute. And outside of the cell, there's 15% solute. Again, the solute's going to move from the highest concentration to the lowest. It's highest in the beaker. So the solute is going to move from the beaker where it's highest into the cell where it's lowest. Okay, for C, I'm actually going to not have you guys draw what will happen to the cell. There's not enough room for all that. But you do need to write what would happen to the cell. So in number 1, we're pretty much just going to think about what would happen as a result of the water movement. When the water rushes out of the cell, if you think back to this worksheet right here, what is a solution? It tells us that when the water moves out of the cell, it's going to cause the cell to shrink or shrivel. Either one would be okay. So shrink or shrivel. Don't need both, just one. Okay. And what type of solution is that? So we have this is D. So we need to give the solution type. To do that, we're going to look at the solute concentrations. Where is the solute highest? Well, it's higher in the beaker than it is in the cell. So Hypertonic, like little kids have a lot of energy. Hypertonic has a lot of solute in the beaker. Isotonic would be the beaker and the cell having the same amount of solute. And hypotonic, like hypo, that would mean that there'd be less solute in the beaker. So in this scenario, because there's more solute in the beaker than in the cell, this would be hypertonic. Okay, so you need what the cell would do and the type of solution. All right, pause the video, try to do number 2, and I'll be right back to show you the answer. All right, so here is the answer. Remember that I wrote my water movement in blue. So again, I have to notice my percents. Inside of the cell, 40% and 60% makes 100%. Outside of the cell, 90% plus 10% makes 100%. My water is going to move from where there's more to where there's less. So the highest concentration to the lowest. So water will go into the cell. My solute is also going to move from where there's a higher concentration to where there's a lower concentration. So my solute is highest in the cell and it's lower in the beaker. This movement of water is going to cause the cell to swell, get bigger, just like we saw in the egg lab. And because the solute is lower in the beaker, this is a hypotonic solution. I know that sounds silly, but I bet you will never ever forget hypo, like Eeyore, the lower amount is in the beaker. Okay, so let's go on to the back where things change a little bit. Okay, so if we look at the back and read the instructions, it says that cells 10 through 18 have a particle size that cannot diffuse through the cell membrane. So that means that we do not need to do step B. So before we begin, you'll see that you don't even have all of your percents. Okay, you have to fill them in. Remember, inside of the cell, the two percentages equal 100. So 100 minus 10 would give me 90%. Outside of the cell in the beaker, you also need to add up to 100%. You have 20%. So 100 minus 20 would give you 80. Now that I have my percents, I'm ready to do steps A, C, and D. Remember, we don't need to do B because the size of the solute causes it to not be able to diffuse through the membrane. All right, again, with my blue marker, I'm going to draw the direction that the water would move. I'm going to compare my water percents. I've got 90% here at the top. In the cell. I've got 80% in the beaker. The water is going to move from where there's more to where there is less. The solute is not able to move, so I don't need to use my red marker and draw any movement. The solute's just going to stay put. I do need to do step C, which tells me to label what's going to happen to the cell. Well, the water is going to rush out, and that's going to cause my cell to shrink or shrivel. And what kind of solution is this? Well, I'm going to compare my solute percentages. And I know that I have a higher amount of solute in the beaker than I do in the cell. That's a hypertonic solution. All right, pause this video, try to do number 11, and I'll be right back to show you the answer. There's the answer. So when I fill in my percentages, I get 60% water and 70% water in the beaker. My water is going to move from where there's a higher concentration to where the concentration is lower. That's going to cause my cell to swell. And when I compare my solutes, I see that this is a hypotonic solution. Hypo, low. There's a lower amount of solute in the beaker than there is in the cell. Hopefully this is helpful to you guys. I'll see you all tomorrow with completed homework, including my post questions down here at the bottom. Those will be completed in complete sentences. See you guys all soon. Bye.